Welcome back. Today we're going to talk about how do we interpret confidence level. So what does it mean to be 95% confident? So, um, as we looked at yesterday, we have a way that we can identify an interval in which is the true mean or the true parameter, the true measurement of what we're trying to get. So what does it mean to set a confidence interval? And so I've got this little staplet here that's going to help us understand this. So what I'm going to do is I'm going to set my confidence level to 95. That's a pretty common one. And I'm going to set my sample size to 5. And what we can do here is I'm just going to show you a sample confidence interval. So here we go. Here's a sample confidence interval. So check it out. So this line that extends on both sides is my interval, right? So this green line represents the actual that I'm trying to measure, right? It's the actual that I'm trying to measure. And as you'll notice, that mean is inside the interval. So my estimated mean, right, is right here. But the true mean is inside that interval. So if I keep sampling here, check this out. I have a bunch of intervals and they slide side to side, right? And they have to because sometimes my measurement is going to be, above the mean. It might be below the mean, but I'm not matching that true, but my interval on either side includes it. So right now, we kind of have this understanding of confidence interval as 95% of the time. I can be 95% confident that if I set a 95% confidence interval, I'm confident that 95% of the time the true mean is going to fall within. Well, check it out. The number of times that my mean, the true mean, has been inside the interval is 100% so far. So here's what I'm going to do. I'm going to just up the sample size. I'm just going to put out tons of samples out there and check it out. I hit it just twice. So the number of times I've done this is 59. And 57 of those times, so 97% of the time, the true mean has been in the interval. Well, where did it miss? Take a look here. Let me scroll. No, that's okay. I'm just going to keep sampling so I can give you an idea. And as I go, check out my percent hit, 98%. So I've set a 95% confidence interval, but because of where it's putting my intervals, 98% of the time it's hitting. There you go. There's one. So this one missed. So check it out. My measure of center right here was over this way, and my confidence interval extended on both sides, but it didn't include the true mean. And that's okay, right? Because sometimes it's not going to, but I'm 95%, a 95% confidence interval, 95% of the time it's going to be within that interval. So watch this. I'm just going to sample a bunch. And check out, as I have tons and tons of samples, like here's a string within about 10 where I had 4 misses. Look at my percent hit, 94%. So it's 373 total intervals I've drawn. 350 of them have hit, so 94%. Well, as I get, I'll just do a bunch. As I do a bunch of these, check out my percentage. Right now I'm at 94, 93, but as I get tons and tons and tons and tons of samples, right, check out my percent. It's locked in at 95% because that's what a 95% confidence interval. If I draw many intervals of 95% confidence, I'm confident that 95% of the time the true mean is going to fall within that range of values. Okay. So what if I change this a little bit? What if I reset this, and what if I put it down to an 80% confidence interval? Okay, all the way at the bottom. Let's sample 100 times. Check this out. 1, 2, 3, 4. Check it out. So 100 times, so 82% of them hit. Well, what do you notice about my confidence intervals? Well, think about it like this. If I am taking a guess at what the class scores would be for the exam, for example, I don't know what everybody's are, but if I want to be 95% confident that I get the mean, am I going to say, I think it was between 90 and 91, or I think it was between 83 and 94. Well, of course, I'm going to have a wider interval, right? A wider interval is going to include more values. And so the chance is greater that it includes the true value. Well, think about it like this. When I set my confidence level to 80, notice how my interval has shrunk. Well, what happens is now when I guess that mean, right, and I have that smaller interval, it's moving side to side, and the arms don't extend as far, so it's not going to extend to grab that mean quite as often. Does that make sense? And so let's extend this all the way out. Let's say we had a 99% confidence interval. Look at those arms, right? So a smaller confidence interval, less percent of the time, I'm confident that a smaller percent of the time the mean is actually going to be in there. But to move it up to a 99.5% confidence interval, look how wide my intervals are. So now when I sample and sample and sample, I have intervals that are wide, and so it's going to grab that mean. It's going to include that mean more often than not. And that's what it means. That's what it means to be 95% confident. To set an interval that I'm confident that 95% of the time the true mean is going to be included therein. And so if I drew all these intervals out on a big long line like this next to one another, I'd be able to see that 95% of the time the mean is included in the arms of that interval. Now, notice, it doesn't mean that the means match. It means that the interval around which the margin of error includes wide enough values that I include the mean in it. Okay, so let's look at a couple of notes here. Interpreting confidence intervals. So let me snag this color. Interpreting confidence interval. So what does it mean? Like I kind of talked about, it's going to be setting a wide enough set of parameters that I'm confident that 95% of the time it's going to capture the true mean. So here we go. If we make blank percent, if we make many, and that's what I was doing, right, with tons and tons of samples. If we make many 95% confidence intervals, we are expecting that 95% of the time we capture the mean. And actually, I shouldn't put the word 95 in there, because those percents are going to match, right? So if I have a 95% confidence interval, it's 95%. If it's 80% confidence interval, I'm 80. I have an 80%. I expect that 80% of the time I capture the mean. Okay, and capture the true. And I shouldn't do this either, because that's just what we were talking about, right? Because it could be any parameter. And so I'm going to say the true, and I'm going to put P or mean, and really it's just a parameter. Whatever I'm measuring. Put it around the mean, I can put it around the, probability, whatever it is. So confidence intervals are not, I'm saying 95%, I'm like a 95% on a test. It's not like that. What I'm saying is that if I make many intervals, 95% of the time it's going to be included, the true mean is going to be included in those intervals. So now you might ask yourself, okay, well, that's great. So you said you had those arms on there that represent the margin of error. So how do they move? Like, what determines how long they are? What determines how short they are? What determines their right and left, right? So the question really is, what affects margin of error? It's a good question. As we increase the confidence level, we increase the margin of error. Right? It makes sense. If I want to capture the mean more often, I'm going to set wider parameters. As I increase sample size, the margin of error goes down. Why is that? Well, check this out. So let's say I pull this up again, and I set my sample size, let's say I set it to 200. okay? And I want, let's go back to a 95% confidence interval. Check it out. I'm going to sample. Look how tiny those arms are. Well, when I have a small sample size, what I'm measuring, that mean, right? Not the true mean in this case, but the mean that I'm measuring, the mean of my sample, is based on 5 people. So I could have wide variability, right? I could have somebody who's got a 5% on the test. I could have somebody who's 100% on the test. And there's this wide variability because of the low number of people. If I increase the number of people, what happens? As I increase the number of people, those outliers, potential outliers, right? Those big and small values, kind of get mitigated and my mean comes to the middle. So I'm actually narrowing down the place where that mean could be because I have this huge sample size. So like to get an idea of what the true mean of the class test score is. If I take 3 people, that might or might not give me something. So to get a confidence interval, I got to have a wide interval because I've got wide variability. But if I take 87% of the class, then that's going to shrink my interval because I know I'm taking tons of data, okay? And so as you increase the sample size, the margin of error decreases because I'm taking into account more variability that naturally happens in the answers, okay? Let's see. Next thing. The margin of error never accounts for bias. So imagine this, you have bias introduced, you do or you don't see it, whatever happens, and we think we're protected because, oh, we've got this wide range of values. Well, if you think about it, the margin of error is based on the values that are represented, which are skewed by the bias. And so we can't just say, oh, I have this wide margin of error, so I must have accounted for the bias. You have to account for that separately. Okay, let's go down to this check your understanding here, and just kind of talk through it. So, as part of a project on response bias, Ellery surveyed a random sample of 25 students from her school. One of the questions in the survey required students to state their GPA aloud based on the response. So you can see why that would be biased, right? So if I ask you, hey, what's your GPA? You might be, and your classmates can overhear it, right? You might be inclined to say, well, you know, it's a little bit higher than it actually would be because you don't want to be embarrassed. So anyway, so one of the questions in the survey required students to state their GPA out loud. Based on the responses, Ellery said she was 90% confident that the interval from 3.14 to 3.52 captures the mean of the GPA for all students at her school. Interpret the confidence interval. So if she sets a 90% confidence interval, what that should mean is if we make many 90% confidence intervals, about 90% of the time, we will capture the true mean GPA. Okay, capturing the true mean GPA. So 90% of the time we'll capture the true mean GPA. So explain what would happen if to the length of the interval if the confidence level were increased to 99%. So think about this. You got a bunch of students in a room and you know that, so let's just pretend we know the true mean is, 3.5. But we've got all these unknowns. We don't actually know the true mean. Well, what we would have to do is we'd have to say, I want to include more values. So I want to widen my confidence interval. So it would widen because the margin of error increases. Right, so we want to account for more things, so we widen our margin of error. How would a 90% confidence interval based on a sample size of 200 compare to the original 90% confidence interval? It would be more narrow. that 200 gives us a better idea of what it might be, because as the sample size goes up, our measurement comes to the middle, right? So it would be more narrow because an increase in sample sizes decreases the margin of error. Okay, describe the potential source of bias in Ellery's study that was not accounted for by the margin of error. Having them say their GPA out loud, like we talked about, that's where the bias comes in, right? People are embarrassed to be embarrassed. They don't want to be embarrassed. So potentially there's bias there. I mean, maybe people tell the truth, but there's potential bias there because you're making people say their GPA out loud. Okay, guys? So interpreting confidence interval, what do you take away from this? Really, the huge points are this. If I make many 90% confidence intervals, 90% of the time I'm going to capture the true mean. That's what a confidence interval means. And then think about margin of error. If I want to be more confident of my answers, I'm going to widen my margin of error because it's going to include more values. However, if I drive my sample size up, you're naturally going to get a better idea of what the true mean is, for example, because of the large sample size. And so that's going to shrink my margin of error because I'm already accounting for some of that variability by having a large sample size. Okay, guys, thanks for watching, and we'll see you next time.